welcome. We are just absolutely delighted that you guys are here. We will be spending the next 90 minutes or so talking about that work. First, looking at what we have accomplished to date with our collaborating utility partners, and then talking a bit about where we think we can go with vendor partners into the future. Specifically, we have a bit of background on our conversation that Randy Rhodes will be starting off with. Then I'll recap what we have done quickly with our vendor or with our utility participants and give you just a brief high-level overview of the architecture the information architecture as it stands at the moment. Then Jay and Scott and Jim and Annette will walk us through what we have in mind with the GMDM vendor forum. That ought to take us up to about noon. And then we can sort of shift into more informal Q&A kind of activity. I have to say that a room full of competitors is not the classic audience that the EPRI team is used to talking to. But I will say the same thing to you that I would say to a room full of utilities, and that is, please interrupt us and ask questions if you have them. We want to make sure that when you walk out of the room today, you know what you wanted to know. With that, I think I will introduce our EPRI team. I'm going to start with Randy Rhodes in the back. Randy is another technical executive at EPRI, and his career spans several utility engineering management positions, a gig with a consulting company, an almost decade-long stint as a Gartner analyst, and then 2.5+ years now here at EPRI with us.
Thank you, Pat. And it's my privilege to introduce another team member. We have Jim Horstman here on our left. Jim will be talking with you a little bit later. I first met Jim many years ago at the SIM users group when I was a utility co-chairman with the SIM group. Jim hails from Southern Cal Edison, where he developed the first OMS there, working with M3I and a number of other vendors. He has really had an awesome track record of implementing model-based integration. They're at Southern Cal Edison over the years and has worked with many of you I know in the vendor and consultant community. So that's one of the things I really appreciate about Jim. The other thing is he has an awesome sense of humor. So. Which I need desperately. So thank you so much for being here today.
So I'm going to introduce Scott Coe. Scott has been a consultant for the past 20 or so years, working with various small and large companies. Now is on his own and primarily working in the market area, but he's more recently been moving into the DER and demand side space. So, Scott Coe.
Thank you. And I will introduce probably someone who doesn't need much of an introduction, Jay Britton. We always talk about bringing teams to a project, and we talk about the combined years. Well, when Jay comes, you get a +50 on your team bonus years. Jay was one of the founders of ESCA, IEEE Senior Fellow, lots of different things, and is one of our thought leaders here on this project.
It's on. Thanks, Scott. And I get to introduce our peerless and fearless leader, Pat Brown, late of Kansas City Power and Light, and prominent in SIM working groups. And you said you won some awards.
I did.
Yeah.
Obscure
And,
IEC awards.
Yeah. Last 10 years, she's been working part-time 80 hours a week for EPRI.
Oh, you noticed. Last but not least, in the back, we have Annette Mosley. And Annette is, besides having mastered the parade wave completely, she is a technical advisor with EPRI. Her usual role is to be the facilitator between our member utilities and our EPRI research programs. In this case, we were lucky enough to get her assigned to our project, where her role will be to help facilitate the kind of buying contracting process for you guys. So we're delighted to have her with us. With that, Randy, I'm going to turn it over to you, sir.
With a group like this, there's really not much I need to say. Y'all represent veteran leadership in this industry. I have a huge amount of respect for all the work that you do. And as I was getting on the plane yesterday morning, I was thinking to myself, how best could I prepare for the few minutes I have to be in front of you today? So I happen to have the latest copy of the IEEE PES Power and Energy magazine, and it was focused on distribution management. So I thought, what better way to kind of prepare? And I read 93 pages front to back. Some of the articles were written by folks who are colleagues of those of you in the room. It was a great interview, a great overview of where we are today, kind of the state of the art. A number of years ago, I went to Washington State University. I live in the Portland area, and I trucked across the state, talked to a bunch of students. I was a Gartner at the time, and it was a career day, and I stopped by and spoke with Anjan Bose. And many of you know Anjan. He's a professor at WSU. He's been in the industry for many, many years. And at the end of that issue is a really great article on the future of distribution management as we know it, and he talks about model-based distribution system restoration, model-based DSR. And we're going to hear a lot about grid resilience, obviously. It's a big focus this week for obvious reasons. So one of my questions, I guess, would be, who doesn't need a network model somewhere, sometime? So we're really diving into the heart of what's behind the scenes that keeps planning going, right? It keeps operations going. So we started this project because EPRI had done a lot of work quite a number of years ago, and Pat will go over that, the background in transmission. And as we began our work with the utilities, we just developed an increasing conviction that we need some really strategic thinking about where this could go in the future. We need more minds in the room. And that was the genesis. All of these needs here are very familiar to you. We've got to get more precise observability. We've got to figure out how to bring that into our simulation environments, how to enable planning and operations applications, and protection, clearly, in new and more effective ways behind the scenes so that this will work like clockwork when it really, really needs to. So that's kind of the heart behind the why on what we're doing. All of these issues are very clear to all of you, I'm sure. The challenge really is it takes a lot of tight coordination. We're finding some of the challenges to strategic thinking in this space is distribution is not just another transmission problem. We can't take transmission thinking. We can bring the best of what we learned on the transmission side regarding model management, network model management. You'll hear that from Jay. And then we can bring it into the distribution space. And that's kind of where the discussion broadens very significantly. And over the last 2 years, we feel like we've taken it far enough with our utility funders to now open the door and say, we can't really do this well without engaging the vendor community. So the diversity of viewpoints, product capabilities, the way in which we start to think about this depends on our backgrounds. And many of us have had decades in the industry, and so we see things through a particular lens. Our goal today would be to step back a little bit, to try to get our minds collectively around this challenge that we're trying to address. So what I'd like to do is just hear from a couple of you, maybe 2 or 3 of you could share with me what brings you here today. What is it about this project that sort of makes you curious? Or is there a benefit that you think you can carry back to the team at your company? And I know you're all vendors and you compete with each other on a fierce daily basis, but who would like to volunteer? And Scott has a microphone as well. And share your name and
Sure. Can you hear me okay? Robert Sherrick with Energy Research Cooperative. I'm doing some consulting work for a software company that is trying to figure out sort of what is required from a distribution planning perspective with higher penetration of DER. And we've been working with 10 utilities over the last year or so, developing some of the major points. And obviously from a planning perspective, a lot of it gets into data issues, data quality, data management, and certainly think that this effort sounds like it would be very useful for the industry and having no enforcement and then at the airport. And, so my interest is really to get some better information about sort of what's being thought about and really try to see how we can evolve.
perfect. Thank you, Robert. Jerry?
I don't know if I need the microphone, but
Yeah, go ahead and use it because we're recording. Yeah.
Jerry Day from IPS Energy. One of the things that we really like to get out of this is one of the things that you set up there, that we can't just borrow from transmission. That's really true. Now there are certain things, obviously, we're going to be able to borrow from transmission when it comes to connectivity on the model, being able to go series and shunt connectivity. That's fine. But when we get into the power flow models and things of that nature, your distributed energy resources, that's really the key is how do we show the difference. You know, if the generation is feeding into the distribution feeder, how do we really show that? How do we show that connectivity? How do we show the power flow and be able to modify that? So that's really one of the things I'm hoping to get.
Perfect. Thank you.
Yes.
Let me take one more. And this time, I guess I'd like to pick on one of our utility attendees. Michael, would you be willing to share a thought or two? Share your name.
Thanks. Good morning, everyone. Mike Pietrafita with Exelon Utilities. I think from our perspective, we're embarking on about a 5-year program to update our GIS system, and along with that comes the whole challenge of data quality. So from our perspective, and we're working with a number of folks, GE is one of our vendor partners certainly, but we're looking to do something that's not been done before, and that is to establish a governance and the process around data quality as we move forward, right? So how do we change thinking? How do we ensure that our data quality moving forward is as tight as it can be? And naturally, I think that was the last bullet on that last slide, but data quality overshadows everything, so we're looking to crack that nut. So thank you.
I know that many of you have customers and that his voice represents what you're hearing. And there's a number of reasons we know that, but in part because we have had this project going for a couple of years and we've done deep dives with most of the utilities. We haven't made it to Exelon yet, but we're going soon. There's some massive projects going on in the industry, and many of you are in the middle of SGIG funding, ARA funding from 2009 to 2019. I feel like this is the next wave, is it not? The next decade of really significant deep development in our industry. So thank you for that feedback. So our purpose is to provide understanding of this architecture to illustrate the value and to help you see where your products play. And this is where we're going to invite interaction among you, to just call out when the time comes and say, we play in that space on the side that provides this information, but we don't play on the side that consumes the information for protection or operations or what have you. So we hope that the value prop will be clear. And if it's not, take me on the hallway. And we'll work on it, because we will have missed the boat. So back to you, Pat.
Do you want to do the what architecture is once, or I can? Doesn't matter? Why don't you? I'll do.
Yeah, let me let you pick it up at this
Okay,
point.
perfect. Very good, thank you. So it seemed like it was a good idea to sort of talk just a little bit about what this information architecture is and isn't. It is intended to be a guide for the industry, both utilities and vendors, to make it so that vendors can implement interoperable, product-based solutions that actually enable them to manage their network model data effectively. Our work in terms of what it's producing includes the identification of business functions that are common to distribution utilities, distribution enterprises. I'll talk a little bit more about that in a minute. It includes a vision of the responsibilities that a network model management business function would need to perform. And it includes defining some sort of building block data exchanges that are common, standard, that utilities can use to actually design local solutions so that they can implement effective model management to the level that their local requirements dictate. So what it's not a recommended implementation. We are hoping what we are doing is creating a reference from which a utility and its vendors can build a local implementation. We probably have some ideas about ways it could be used well, but that's not the purpose of what we're doing. And it certainly is no statement on what tool, what system, what application should support what business function. I mean, if you learn nothing else in talking to utilities, it's that there's a huge variety of both systems and the business functions they serve, and they are sliced and diced in ways that are very different from one utility to the next. Okay, with that, let me talk just a little bit about our project to date, and then an overview of the information architecture itself. Gosh, all of you know by now that we have been working with utilities in this, the name of it is Distribution GIS and Grid Model Data Management project. That project kind of by the numbers looks like this at this point. At the moment, we are working with 11 utilities. We are adding a 12th as we speak. They have been delightfully diverse, right? They're on 2 continents in 3 countries, very different climates, very different sizes of utilities. So it has been just a wonderful cross-section. We've been working with them for a little over 2 years. We have done in-depth work with 6 of them. We've got more scheduled over the course of this year, and we have gained just a lot of real-world insight from working with them. On Wednesday of this week, some of that insight will be shared by a couple of our utility participants and me in a panel session. It's a mega session, and Randy's actually going to be moderating it. And yeah, complete disclosure, the information architecture talk that I'm going to give here is borrowed liberally from what we will be saying on Wednesday. So if you look at what EPRI has done over the last 7 years or so in the domain of network model data management, we started in transmission. And it's natural in transmission to think, oh, you're exchanging network models, you must be doing it between utilities. Well, it turns out that even in transmission, the real challenge and the real value of managing network model data well is if you can organize the data that is shared among applications inside of the utility. So our distribution GIS and grid model data management project took that work down to the distribution level, and the aim there is to define an information architecture, right, that utilities and their vendors can use to actually implement solutions that help utilities manage their network model data well, stem to stern, planning, protection, operations. We were fortunate in our in-depth work with the utilities to be able to sort of go into utilities, see how they do business, but be wearing a set of glasses that was looking at what we saw very much through model management eyes. Now that was really the thing we were interested in, was network model data and how it was managed. And what we found, none of this will surprise any of you, widely varying patterns of implementations, right? Where design engineering is done, what patterns of tools are used, what they're used for, whether or not projects are used at all in the management of data across the enterprise. So lots of different patterns. We saw such high volumes of changes and so much data that there was lots of automation. And if you combine that varying solution patterns with the need for lots of automation, what that says, of course, is that you have lots of proprietary custom interfaces that are actually enabling that automation. We also found sort of everywhere the difficulty of crossing that boundary, of transitioning from a fundamentally facilities, civil, structural, geospatial view of the world to one that is more electrical system based. It's just tough to do that. I think it would be safe to say that every utility that we worked with recognized the value and importance of effectively managed network model data. They know they need it now. They know they are going to need it more 2, 3, 5 years from now. But pervasively, there was difficulty in implementing those kinds of enterprise-wide, overarching solutions that are what are really needed to be able to effectively manage network model data. So it is our hope with this project that what we are able to do is define a reference architecture that utilities together with their vendors can use in order to actually kind of tackle that daunting challenge. So before I get into the details of the information architecture, I wanted to share sort of 3 foundational philosophies that are just, I think they form the basis of where we started from. And these are general data management philosophies. They're not specific to network models, but they go kind of like this. If you look at the responsibility for managing data of any kind at a utility, that responsibility is shared between the utility and the vendor. I think if you look at an application, it's very evident that it is shared because the vendor provides the schema, the data management capabilities, the utility figures out how they're going to use those capabilities, the utility populates the data. So lovely shared responsibility. But my pitch to utilities is that if you look at that space between applications, between systems, the vendors don't play such a big role. They shouldn't play such a big role. It's the utility that knows what data they put where. It's the utility that knows how they're using the tool. It's the utility who knows what the business processes are they're trying to support. And a utility can abdicate that responsibility. All too often, I think they do. I think when they do that, what they risk is losing the value of their data across the enterprise. So it's always been my contention that it's on the utility to manage that data as it goes from, or to design the solutions for managing that data as it goes from application to application. There is a best practice in how you manage shared data if you are a utility and you're taking responsibility, and it's called semantic model-based integration. It basically says that you define an information model that is understood by all of your suppliers and all of your consumers. It calls for a very concisely described information model that describes the meaning and the structure of shared data. And you use it in every data exchange, every place in your company. It's implemented by putting translators or adapters on each system to translate from the internal structure to the semantic model structure. But yeah, that's it. And that's a really tall order for any utility, right? That's your job, Mr. Utility. Define a model that covers all of your shared data. And by the way, don't implement 1, but implement 2 adapters, translators every time you want to share data. So it's kind of the third precept that makes this theory feasible at all. And so just imagine that you had multiple utilities who all agree on a shared semantic model. I would save each of them a huge amount of work in designing a quality information model. And then imagine those utilities could look to their vendors and go, we're all using your tool. Could you put an interface on your tool one time that we could all use in all of our utilities? So that's basically where the grid model data management information architecture starts. We want to define standard data exchanges that are in conformance with an industry standard semantic model that vendors can put as interfaces on their tools, and the utilities can then use those tools, combine them in whatever way they see fit, and actually come up with solutions that implement effective network model data management. So before I talk details on the information architecture, I thought I'd talk just a little bit about the development of it. We started very much with the work with our utilities. What we saw there, the patterns of requirements, the issues, the really good implementation ideas, all of those informed the work that we did on the information architecture. We, as you can kind of tell by some of the introductions this morning, managed to assemble a really good team of folks with data integration, and power system engineering chops. So just a really robust team. I will tell you, the work was more difficult than I thought it was going to be, because developing an information architecture for an industry is not the same thing as designing a really nice, elegant solution for one utility. There is a world of knowledge and expertise about how to do the latter. The former, not so much. We needed to design something that was of universal value to utilities who were going to deploy products by a variety of vendors, something that they could leverage, where they could leverage standardized data exchanges to actually build local solutions that were what they needed to meet their requirements. So as we started looking at tackling the information architecture challenge, we did so by looking at something that all distribution utilities share, which is those business functions that facilitate the planning and the operation of a distribution grid, because that's what every utility does. So we decomposed those business functions to the point where we could kind of see where the information was coming from, see where the information was going to. And doing that kind of decomposition allowed us to see requirements and characteristics, things like the fact that while all of those consuming business functions need network models, they need different extents of the grid, they need different levels of detail, somebody needs short circuit parameters, somebody doesn't. They need different points in time. So some variation there in what the consumers need. But if you look at the sources, there were some universal things that were true about them. For example, that they have a more localized kind of physical component perspective on life, not an electrical system view, and that when they provide data, they tend to provide a small certain type. Like, I can tell you about meters, I can tell you about relay settings, I can give you measurement point names. So it's much smaller amounts of data, more specific ones, and certainly no kind of overarching electrical system view of the world. If we looked a little bit farther at specific information flows between supplying subfunctions and consuming subfunctions, to me what that picture does very clearly is it calls out the need for a business function that does nothing but manage network model data. It's very useful to look at the world, I think, in that fashion. That is a business function whose job is to gather master source data and to manage it, store it, massage it, work with it to get to the point where it can supply those consuming systems with what they need. Focusing kind of down in a little bit more on the network model management business function, you can divide it into sort of two business sub-functions. The first of which is managing master model data. So keeping an accurate description of the grid yesterday, today, and tomorrow. And then the other function of actually preparing cases or models for consumers that need them. Those two business sub-functions work asynchronously and simultaneously. And the master model maintenance business function really is driven by changes to the grid. That's what affects it. The master case assembly business function is all about the need to do studies. Something has to happen there when somebody needs a model in order to do a study. if you have a tool that implements the network model management business function, you are talking about a tool that is consuming and producing shared data. That's what he's doing. So it kind of makes sense. Yeah, you maybe ought to be looking back at one of those semantic models. Well, thankfully, in the world of the electric industry, you don't have to look very far. We have a common information model, and it is a very nice, pretty mature semantic model that can be used by the industry. The SIM, in terms of its view of network model information, recognizes sort of two major types of information. It provides constructs for managing power system data itself. So descriptions of equipment, connectivity, equipment parameters. But it has another type of information that it models, that it has constructs for. And those are constructs that enable the management and sharing of that power system data. So things like models, things like change models, things like assemblies. And as you can tell, they are all sort of containers of that power system data that allow you to manage and share it. Now, I'm not going to go into the power system modeling features of the SIM. That would be like a 3-day course. But I do want to talk a little bit about how those constructs that allow the management and sharing of network model information can be used to describe what we expect a model management function to be able to do. So start with master model maintenance. And that master model maintenance subfunction has foundationally the responsibility for maintaining a detailed model of the electrical system. And we would say it would be doing it in pieces. Those pieces can be defined in a local implementation. They typically would reflect either patterns of supplying, of sources of supply information, patterns of needs in terms of extensive of cases or models that consumers need. Lots of different ways of approaching that, but it's a very, very powerful concept to manage that master data in grid extents. So in addition to managing that master detailed information, responsibility that this master model maintenance business function has is to manage changes to that. And I mean changes from the time they are thought of and approved, through the time they are designed, through the time they are constructed, commissioned, completed, whatever. So managing those changes, future changes to the grid. Another responsibility of that master model maintenance business function is keeping history. And that history is updated when a proposed change completes or gets commissioned, and then is incorporated into the next version of an as-built of a model. So that's what that underlying guy that just keeps chugging away, keeping track of the existing grid does. Yes, question?
I want to ask what I hope is not a dumb question, but when you say manages the master data for different parts of the grid, do you envision that being different parts physically of the grid, different areas within the grid, or do you envision that being different parts of the grid, such as the protection model versus the MLSE model versus, I mean, are those what different parts of the grid are you speaking of there?
So the SIM gives you a number of ways of slicing and organizing information, right? Profile. Oh, I'm sorry. Yes, yes. Jerry's question was, in what fashion is one of those model things subsetting a grid, right? Is it by type of data? Is it by grid extent? Is it by, whatever, right? So in this case, the SIM gives us lots of ways to slice and dice stuff. This way of slicing and dicing is specifically about grid extent. And see, Jay's just over here itching.
Yeah. The correct
Go away.
answer is both.
Okay. That's the easy answer.
But Pat's main point here has to do with extent.
Right.
So for example, a model could represent a single feeder. A model could represent a part of the transmission system.
Single circuit.
Yeah, and you get to decide what the extent is. It's
Right.
not dictated to you what you use. you conceive of the best way to divide up your model into components. And there's sort of two rules about it. One is, where is who is the authority that's managing that data?
Right.
You don't want to have multiple authorities in the same model to the, and the other one is, when you're building a consumer thing, you'd rather be dealing in complete models. Just adding complete models together, it makes the building a consumer thing easier.
Makes sense?
Yeah, it does. I just wanted to make sure that when I was envisioning these models, I'm envisioning it the same way that you're envisioning it.
Yeah, good extent. Yes?
Hi, Hormuz Kazanzadeh with OSI. I'm going to step back a little bit on your business function
Yes.
map. I didn't see GIS.
You're right.
There's a business function, and we're talking about network model management. And I mean, from a transmission perspective, great. Yeah, transmission, you just people create their own models and all of that. But in distribution, we get all the data from the GIS and all of these things. So is GIS group going to own this? Is it a separate group? How is it going to coordinate? Maybe you get to it later, but that's a gap that I see.
You ask the million-dollar question, frankly. One of the things we learned from some way early work we did with DTE was that it's really essential to separate out the business function from the system that's implementing it. You can't have a civilized conversation if you stay with your feet in the system world, because everybody uses their systems differently. So you really have to talk in terms of business function, and I think what it makes a lot of sense to do is say, I have a system that only does this business function. I have a system that does bits and pieces of business functions out of a variety of areas. And Jay is going to say something here too, and that's a good thing. But to your question about GIS, in my view, you have, let me just back up, because there's some, I mean, you can kind of do some pointing at some of this, I think. Yeah, get rid of you. A GIS clearly is doing some facility record management. Many GISs do design, but not all of them. Not all utilities. Oh, you want me to use the pointer? Okay. Sorry. Not all GISs, not all customers are going to use a GIS to do their actual engineering design. And GISs do a lot of network model management. But I think from an architectural design standpoint, it was really important to kind of back up and get away from the, what is it that an actual system used at an actual company is being used to do. You can't call it that way and come up with any kind of a design that makes you really understand how data needs to be managed. So that's why there's not a GIS. The SIM has a reference model that I think has called out GIS as a business function, but it's really not. It's serving lots of different masters, the typical one. Okay, somebody who's got more better different.
That's a good, yeah.
All right.
GISs implement a lot of different business functions. We wanted to avoid the utility-specific choice about what business functions were allocated where. You can talk, there's a lot more commonality among business functions at a utility
Right.
than there is implementations at a utility. Same goes for DMS. You won't see DMS on the chart. There's labels like operations or operations planning.
Mm-hmm.
And we're interacting. This is working.
You have to talk loud.
Where's the other mic? So for those of you who know the SIM IRM, we're interfacing with that. I'm going to be talking a little bit more later about how we're interacting with the IEC working groups. There is a geospatial information tracking. I think it's something along those lines. So there is a function around tracking geospatial information. And absolutely, we've been looking at those pieces of information coming in. And as Pat said, there's lots of different information coming in. The GIS is one of the suppliers of this kind of information, among other systems. Any other comments, questions? Yeah.
I'm Brad Williams with Oracle, and had a question around that. You had a little bullet about the time dimension or the
Yes.
time frame.
Yes.
So obviously, distribution networks are very dynamic. There's
Yes.
constant switching, constant new connects. There's a lot of activity. So can you just talk a little bit about, are you expecting to have different models every time there's a new connect, or is it like an incremental? Are we going to be able to have like a little slide bar that says, okay, look at this? What's the vision for the dynamic nature of the distribution network model?
Isn't that near future model?
Well, what about 2030 model for planning and?
So the general philosophy is that if you want to create a new version of a model, all right, so we're talking some subset of the grid or the whole grid, whatever, you want to create a new version of it, the way you create a new version is by adding a set of changes to the existing one to create a new one. So yes, there are changes. Now, in the most classic sense, many of those changes are going to be something that happened in the field, a construction project, right? Maybe it's just a little bitty one, maybe it's a gargantuan whole new feeder, whatever. But most of those change models are probably projects. And I think the sort of a foundational concept of the information architecture that it is those changes and their purpose that is what you manage. It may be a little tiny thing. You may be doing nothing more than changing your philosophy on ratings, and maybe you're doing it across a lot of devices. Or you're correcting something, or you're saying, I changed out this one transformer. But the bottom line is, that's a change. You want to track it, and you want to know why it happened. So yeah, it's very much a matter of viewing the evolution of a grid over time as a series of changes that you periodically snapshot into a version. And you could do it with every change, right? No, not saying how far those snapshots are taken, but that's the philosophy about how you move forward. And it's that kind of thing, frankly, that gives you traceability, the ability to do an audit trail and that kind of stuff.
Brad, so were you also thinking about the level of detail that goes into the change? I mean, if you're talking about a 2030 plan, that's a pretty high level of detail versus here's some construction we're going to do tomorrow. So there is that distinction between kind of the high level plan, we're going to do something like this here, or even like switching, as we used to do at Edison, we did summer, winter switching along the coast. So you put that in, and that's just switching as opposed to any new construction.
Right.
This change model is a really important concept, and it can be something, as Pat was saying, as small as one rating change. It can be as large as a brand new feeder that's being added to the grid. And the whole idea is that you define this thing as soon as you know about it. So if you're planning for a 10-year out grid expansion, you can build a skeleton of a change model with a few pieces of information. And as you get more information, more detail, more design, you build that change model to be more accurate. And then at some point, the change becomes constructed and real, and it folds down into the model itself.
Just one more point to that. And I think as we start looking at the longer term planning, we're going to need to be looking at scenarios like EV adoption rates, which will be kind of targeted spatially, and which will be different than other types of scenarios that we'd need to look at. So I
Yes.
guess as you get closer, you say, okay, now we're going down this path, and this is the model we're going to.
Yes.
Multiple future models that you can have at one
Build.
time. Yeah.
Correct. So you created a new version of the as-built. Okay, so that does that guy. He's just keeping track of the way that the grid is, and maybe into the future. The other subfunction, the model case assembly subfunction, uses these building blocks that the master model maintenance guy is keeping up to date all the time. And it uses them as input into something that is just generally called operations. So operations might be putting the right projects in to move a model forward in time to the time you want to study, Or maybe it's adding in the changes that that wind farm is going to imply. Maybe it's doing nothing more than looking at the configuration you have right now and calculating operating limits for that model. Maybe it's reducing a model because you've got a consumer that doesn't want all of the detail that the master model has. So there's a set of operations that can be done. The output of an operation is always just another model. And then models can be assembled together to create the network modeling that each consumer needs. So that's what the responsibilities of the model case assembly guy are. So in part to your question, Brad, that's kind of the answer. That's where the rubber meets the road in terms of building a model or a case that meets the needs that you have. You're able to pick and choose the parts that you want to include in it.
Address, I think, Jerry's question earlier, so those two models could be two different voltages. They could be two different regions that are being stitched together, or some combination of all those things.
All right. So we've talked about how we started with a business function approach to things so that we got universal requirements. We've talked a bit about using the SIM to describe the responsibilities of the network model management business function. And we're wrapping up our architecture work as we speak, defining some significant use cases that basically say, if you had a tool that was implementing that model management business function, how could it be leveraged? What could it do to serve the needs of the systems that are implementing the other utility business functions around it? So that's kind of where we're at the moment. But we're real cognizant of the fact that the work that we have done so far, which we think is good, but it's based only on what we're hearing from utilities. It's based on their requirements. What it doesn't take into account, which we think is the other half of this, is the vendor side of the world. And it is because of the fact that we realize we're really not done yet that we are launching the GMDM vendor forum. We are hoping that the vendor forum improves the architecture. We hope that it helps refine the SIM to support the architecture, and we hope it is able to make it so that we can demonstrate the value and feasibility of the architecture. With that, I think it is time to go to, who's kicking off this part? The GMDM vendor forum. Jim, it's you. All right, a clicker. Yeah, well, no, why don't you do that? Well, if he does this, then you don't have to hand it once, so I think you're in
And
good
I can
shape.
put this down here so it'll make the pounding sound. Sorry.
Yeah.
Okay, is that working? Okay. I can never tell from. I probably need the clicker too, don't I? I'm going to stand on this side just to mix it up a little bit. That's. Randy's telling me you can't hear me. Is that better?
A little bit louder would be good.
Okay, I'll try to talk really loud. Okay, so again, why the vendor forum, and Pat pretty much talked about that. We need input on what we're doing. As Pat mentioned, we've had 11 utilities involved, plus one more on the way, got a lot of input from them. Scott mentioned the over a century worth of experience that the team has brought, a lot of which is between Jay and me, and I added it up. I think it's closer to two centuries, because Jay and myself add up to about a century ourselves, but we need more input, right? I mean, my background is large utility, large distribution. I can bring some experience in that. I don't know much about smaller utilities and how they operate. So we need that breadth of experience. We'll talk a little bit about the sequence activities. What is going to be involved in being part of this forum? What's the value proposition? There is some cost and some expectations from the vendors on here, and then how we're going to ensure success. So again, what we're looking for is that the vendor input on this will improve the architecture. We've done a pretty good job, we think, so far, but we need some more input. Pat mentioned use cases. So have we covered a sufficient number of use cases? Or are use cases that you see out there that we haven't covered? And what you're doing with the utilities that you're working with? Are there other things we need to be looking about to take into consideration in this architecture? So from that standpoint, vendor input makes this more real. You bring a lot of experience too with what you've done, and so that helps us get to an architecture that represents what's really needed out there. Okay. So, from the standpoint of what we're going to be doing involving the vendors, the sequence of activities, first off is getting everybody on the same page, bringing everybody so everybody's up to speed, feels comfortable, get all your questions answered. So again, today we'd like any questions you have them now. We'll have time for discussion afterwards, bring everybody up. So we're all at the same point. Agreeing on where we're going forward with this, what are we doing, making sure again that everybody's in sync on what we're doing, what the end result will look like. Some activities around refining the SIM, as Pat mentioned. The basis of this is the use of a semantic model, which in our case would be the common information model. We know it needs some refinement as we move along here. Primarily for those who are familiar with the SIM, that lies in the working group 13 area. I think there might be some working group 14 changes too that will be required there. I know, for example, in the OMS area, a lot of times you're showing the real asset information, not just the network view of the world. So there may be some requirements for working group 14 there. We will be having an interoperability event to test out if the vendors have met the requirements of the architecture, can demonstrate that they support the architecture. And then we'll have some deliverables out of this. So all told, we're looking at about a 1.5 years, 19-month effort for this. Okay, so a little bit more in depth on the getting on the same page. So if you don't have a background in the SIM or need to get brought up a little bit more to speed, there will be some SIM-related training. Some of it will be conceptual, some of it will be more the details of it. Some webcasts will be involved in that. Those will be recorded, so if you miss the webcast, you can go back and catch up on it later. And a lot of opportunity, again, for questions and answers to, again, get everybody up to speed. Review of the architecture of where we've got it to date. So we'll have some webcasts on that to overview the architecture. Again, looking for Q&A on that. And then the opportunity to review the documentation that's being produced. So here's 2 examples of the draft documentation that's out there already. And again, we're looking for feedback from the vendors on those documents. And it's not just feedback, it's input to those documents.
So now we're going to flip to the next page. Click for me. No, I'll just go here. We're going to flip back and forth. So that last point, I want to re-emphasize that you will have the ability to look at some of these documents before they are published, so you are not surprised by what comes out, and hopefully you get your thoughts into them. So some of your ideas and some of your product roadmap is actually built into what we're doing. So I don't think that's a minor point. So the other thing to think about what we're doing here is that we don't, even though we've got a schedule laid out here, we don't have a hard plan in place. We want to build that plan with your input. So this is kind of our skeleton. And over the next few months, we're going to be working with those of you who sign up to define what we're actually going to do in this project. So that means talking about what exchanges we are actually going to be doing. We'll probably pick a handful of exchanges. Likely we'll want to exchange a complete model, the equipment model, maybe some dynamics or geographic information. That change model, so a project, a change to a model would be exchanged, and what we call a fragment, which is any piece of information like a set of meter installs, some data that's come in from one of those supplying systems that goes to inform a model to bring it up to speed. So those are likely candidates, but we want to work with you to specifically pick out what are the things we would like to test ultimately in the interoperability test. So the first few weeks and months will all be about getting discussion going among all of you to find out what are you interested in doing, so we know what a good effort, what we should focus on in this effort. Jim, you want to talk a little bit about the feedback to the sim? Or I can do it if you don't want to come back up.
All right, so again, what we're looking at is, in part, some refining the sim. What's not in the sim that we need to have to support this? So as we develop use cases, identify the key data exchanges related to those use cases, going back and seeing, does the sim support those data exchanges? So if not, then we'll go in and figure out through the working group mechanism how to get those changes into the sim. What are those changes? And get them in. Again, this will be, EPRI will lead that effort within primarily the working group 13 contexts. So this could be for some basics of, just what is the model? How is network connectivity represented? Do we have that right? Is there any changes to that? Could be, what is the content? What are attributes it might be? So on. So the goals then are sufficient semantic model and data exchange clarity, support interoperability testing, again, because that's one of the real highlights here is to get to demonstrating that this does work with the vendor products, between vendor products, and it will work between vendor products and utility other applications. So again, we're looking to be able to come up with those extensions to the SIM that will be eventually incorporated through Working Group 13.
So show of hands, how many of you personally or your company has worked on a SIM interop or interoperability test? Okay, so about 50%. For those of you who have not done this, it's a process of bringing together a number of vendors and having a defined test case with some data already set up, and you run that exchange through and make sure that it works. And at the end of the day, you get a certificate that your application was able to successfully process that test case. So at the end of the day, you have something that shows that you were involved in this, you're compliant with at least some subset of the standard, and that you're participating in our effort. So what are we doing here? We're trying to plan for one of these interoperability tests. We think probably the fall of 2021 is a good target for that. Likely we would do this at our EPRI facility in Charlotte. There will be, in addition to the vendors who are participating in the exchanges, there'll be test witnesses, people who are witnessing what's going on and helping with the data, building some validation tools, test harnesses as they're called, and there'll be some training for those test witnesses. We hope to leverage the UCA IUG because they're the organization that have done these sorts of things in the past. So there's some work up front that will be starting fairly soon to sort of get ready for this event. There's a lot of long-term planning, especially around getting the data and the test procedures ready. And then ultimately, we end up with the interoperability test. And the purpose of this is to, of course, demonstrate that all of your work up to this point has been fruitful and the exchanges will be successful. So we'll have some pre-events, sort of a safe test run, try to debug some of your issues as they come up in a nice quiet environment, and then the official interoperability test where we'll have a number of people watching what's going on. So we hope this will be a very big event and get a lot of publicity out of it and get a lot of people who weren't really aware of this activity, this GMDM effort. Really, this will shine some light on it. So at the end of the day, what do you get out of this project? You get a certificate that says your interface, your product has successfully passed each test. And you may have some tools that work with some of the tests and other tools that work with other parts of the test. Remember, there's some tools that are what we call fragment providers, providing information up to the model management. Some of your tools may be model management tools themselves. A lot of the GIS products will be a model management tool. And many of your tools will be analysis tools that consume models. So you may fill 1, 2, 3 of those spaces, and as many or as few of those roles that you would like to play, you're welcome to play. But as Pat mentioned earlier, we want to know from you as soon as possible where you think you fit in that overall picture so that we can develop test cases that work for your tool sets. There will be a report, of course, listing your participation. And then ultimately at the end of this, there will be interfaces that we think the utilities will start to be asking for, and your tools will already have been certified to provide those, and you can use that as a marketing lever. Any questions on the interoperability test, the process, what we're trying to lay out here? There should be some. Question back in the back?
Fill me in with Esri. What's the role of IEC in relationship to the certification? You know, we're getting a certification from EPRI, not from IEC. How is that going to work?
I'll just speculate right now until, Pat, do you want to do it?
So the IEC does not do certification, they don't do testing, but the UC-AIUG has been, along with EPRI and ENTSO-E, has historically been the collection of entities that sponsored interoperability tests, and everything in the net, let me just say this, everything in the network model end of the SIM, the interoperability tests done on those were done for the purpose of proving the standard, not for the purpose of thumbs up, thumbs down on a product. They're not certification, they're not compliance. This is definitely not certification or compliance. This is very much, did we manage to define something well enough that it can be made to interoperate by different vendors? Okay, so the world is used to the EPRI, ENTSO-E, UC-AIUG in the form of the SIM users group actually sponsoring interoperability events. And so it is not unusual at all for those entities to be the ones that put out certificates of participation, certificates of compliance, whatever. In our case, this is going to be certificates of participation, right? This is, again, this is not a thumbs up, thumbs down sort of thing. And one other quick thing I wanted to point out is that it takes forever to get a SIM standard pushed through. It's in the magnitude of a couple of years. And so obviously in the duration of a project like this, no matter how well informed we are, no matter what a good job we do, what's going to be in place at the end is not it won't be an IEC standard. Now, we are doing everything we know how to do to make sure that the work that we do is done within Working Group 13, that it has the participation and support of Working Group 13 members. There are more than one of them in this room already. So we think we are setting ourselves up to have absolutely the utterly best chance of having everything that we do actually end up in a SIM standard somewhere, sometime down the road in another 2 or 3 years. But it seemed really important to make sure we had defined things well enough, do the interoperability test, have those specific data exchanges defined, and then publicize them, right? If an EPRI report comes out that says, you know, here's the interface, it was designed inside of Working Group 13, and it's the, you know, this collection of vendors interoperated with it. I think that's what we can expect in the world of interoperability sort of certification. Okay, sorry.
I'm going to step in here just a little bit because I want to add some emphasis. First, let me check. Bill, describe the clarity of what she just said on a scale of 1 to 10.
7.
So I have watched interop. I've watched interop initiatives, exercises, efforts from within the industry when I was in the utility as SimUG co-chair. I have watched it from Gartner from a distance. I have now watched it from EPRI over the last nearly 3 years. And there are successes and there are what looks like from the outside abject failures, you know. So it's a tough nut to crack. The reason I'm saying this is because when I turned to Pat about 4 months ago and said, I really, really think we need to get the vendors in the mix here, and how can we do it? My thought a day later was, we've got to put a stake in the ground where commitment to the vendor forum means a commitment to the interop. So the structure of this project is all aimed around early engagement from the vendor side in how an interop would best take place. We've got great examples over on 61850 side of the world. You know, 250, 300 people in a building for 4 days. We did that at EPRI's Charlotte facility last spring. When we get over to the 61968 side of things, working group 14 or some of the working group 13 stuff, NSOE, we've got some great examples there. But on the distribution side, not yet. And it's reflected in the clarity. And if we can only get to a 7 at this point, it's not a bad thing. It just illustrates the challenge that we have. UCA, IUG does want to be a certification authority. They've been working on it for several years. And that's all I'm going to say at this point. Now, where are we on a scale of 1 to 10?
Oh, maybe 7.5. What I was thinking is, will they make, I don't even know if I've never needed a mic, for those that know me. Yeah, put it down, yeah. Would there be some kind of acknowledgement on the part of the IEC that says, yeah, this is really of value? And I think that's what kind of I'm getting, as opposed to certification, but, you know, recognition that we're doing this and that it has a substantial value to the industry. And I'm wondering if there will be a statement about that, or will be some acknowledgement by, say, Working Group 13, 14. That's a 7.5.
No, I think the indication of value comes if you see our work go into a standard. That is like the gold standard that you succeeded, and that's what I said. I think we are trying our dead level best to make sure that the collected activity of this group ends up being something that finds its way straight into some 61970 standard. Okay.
Those
8.
Let's go to 8. Here, 8.2.
those acknowledgements have typically happened in previous tests, but they typically don't come from IEC. They come from other bodies that you should be able to trust, but not the IEC.
And the working groups will almost certainly be aware of this, and many of the people participating, whether it's an actual, you know, in the IEC documentation is another story potentially. And then before, I know there's another question here, but there's also the role of the observer. So if you don't have an interface to test, but you want to be involved in this effort, you can be an observer. Our utility partners are encouraged to be those observers, but there are folks from the vendor community who may also play that role. Pat?
I just want to say, though, that at first cut, if you have a tool and you want to come to the event, you ought to come as a tool vendor. What I don't want to have happen is for folks who are tool vendors to look at somebody that's their test witness and go, that's Fred, my competitor. I don't want him. Right? So with system integrators makes lots of sense, I think, as test witnesses. Our utilities total senses as test witnesses. I'm a little bit hesitant on that. If you have a tool, you know, maybe the way you come in the door is by interoping it. Anyway, and that's a discussion for, right, that's a discussion for later, but I wanted to make sure people were aware that we're sensitive to that.
And that would be why we have some system integrators invited here, and we have some in the room today. So we do feel that's an important role.
Now we've made Jerry wait long enough.
I just wanted to add, maybe for clarification, maybe this helps, maybe it doesn't, but what I heard, and I'd put you more at around a 9.2, 9.3, at least from what I heard, okay, because what I heard was before there can be a standard that everyone can follow, we have to show that we have something that everyone can follow. That's what I heard.
Yeah, that's an important point. It's feasibility demonstration here. And there's actually, there's certain kinds of standards where you really have to achieve out-of-the-box certification, because that's the way the products are bought. They're produced in bulk and they need to work, period. A lot of the stuff that we're talking about here is not of that nature. You're trying to do something like integrate with a control center. You're not going to buy a new control center in order to make it integrate. What you're concerned about is, can I take this product in and make it play with my control center in a reasonable amount of work, like a couple of man-months worth of work to make the interface go. And so demonstrating feasibility is actually the real goal in many cases.
9.2, is that right?
That was at least our goal. So this slide here is really about the value proposition, and we've kind of covered a lot of these points, but why should you participate in the vendor forum? Well, certainly, as we talked about, it's an opportunity.
This one was mine, actually.
Oh, is this yours? Sorry. Go ahead.
But you were doing great.
Well, okay. I thought you were going to do the page after this.
What's that?
Go ahead, Jay.
All right. Where is the clicker these days? Yeah, I'm going to talk a little bit about the value proposition, and there's some nice words on this slide, which I'm not going to spend very much time on, especially these first three, because they're important, but it's kind of motherhood. Do you want to be a leader in the field as a vendor? Participate, because it gives you the opportunity to influence the architecture. It gives you the opportunity to influence the SIM directions instead of getting something handed to you that you have to bend your product to. It gives you a reputation as a leading vendor. You get lots of good publicity out of this. I'm going to spend a little more time on this last item, the improve the positioning of your products, because I think one of the things that to date, especially in distribution, products have been popping up here, popping up there, popping up here. They're overlapped in many cases. Compared to transmission, for example, there's a lot more kind of craziness of multiple implementations out there in the industry, and I'm hoping that what we're doing here, among other things, is to help vendors position their products so that they can be successful, the vendor can be successful, and the utilities have a clearer picture of how to take first-class products and put them together into a system. So I'll just bring up an imposing slide. Now, Pat, yeah, obviously you can't read all of this, but Pat put this first one, the same slide up, except she did it in overview. There was, we had network model management. This is planning. This is operations over here. This is facility records management, facility engineering, asset management. All the same sort of big boxes are on this drawing as were on hers, but this has gone down a level. And I'm not gonna give you a complete tour of this. I wanted you to know it exists. And part of what should be happening in the project is to verify and maybe detail, especially in the areas we're going to do interoperability testing, produce a bit more detail level, maybe another level down from this that guides our work. And I'll just give you a little bit of an illustration in a couple of areas of how this works. The first one, what do you need to do to get this to pick up?
You gotta think really hard about it.
Yeah. There we go. So one of the things you can do with this diagram is sort of map out use cases. And this one is a customer connection request. For example, a DER facility that a customer wants to connect. This has been a hot topic in some of the SIM phone calls lately. And you can see the steps on this diagram. Number one, customer submits application to connect. That's down here. There's a customer-facing business function. There's that guy right there says customer connection application, and that takes it in. And here you get some convention here. The rounded boxes are business functions. The white squared items are data sets, important data sets that are produced by that business function. The idea of this is to describe business functions in terms of what major data sets do they produce and what major data sets do they consume. So step two, if it requires study, in other words, this turned out to be a DER that was big enough so that it got flagged here for needing study, and it would get sent up to network planning. So that's step two, and that's a data exchange that goes, oh, I wanted to mention one thing. The purple world down here is facilities, individual facilities, but all about the facility, all the details, civil engineering as well as electrical. The blue world is network model-based, electric system model-based stuff. It's concerned about the whole electric system and not about, a lot of the civil engineering work aspects of things. So this is going from the purple world to the blue world with some data about the DER. Now, if network planning needs to study it, the first thing it needs is a study model. So it's got to go to network model management, and it's got to run a consumer assembly procedure that it designed in order to produce a future state case. What's the system going to look like when this project goes in? And he does some planning work as part of step 4, and eventually he gets to an idea about approving what it takes. Probably, since this was a major, it probably takes some utility work as well as what the customer did. So it's probably actually 2 as-planned changes that get produced in step 5, and they go back into network model management. Very important, they go back into network model management so that anybody else who is consuming a network model for the time period that this thing is contemplated for is now going to see it and see that as part of, and I think Brad was going to this a little bit in some of your questions. This means that as you're taking in all these customer connection applications, you're building up a picture of the network model in the future of how much solar and wind and batteries and cars and all that kind of stuff you're going to actually have on the system. So we get that, and at some point, when the engineering guys are ready to work on this, they're going to take this back down from the blue area into the purple, and they're going to develop maybe they're not going to do anything to the customer proposal, but they're going to develop feeder design improvement if it was in the distribution system, do whatever the utility need to reinforce the network. And when that happens, that engineering work produces a new update of this project, a better, more complete view of that change. So that gets into the as designed change update, and that was the end of this little use case. That's just a little illustration of the kind of thing we're trying to get to on this. And if we were looking at any particular area that we decide as a group to zero in on, we'll try to do this sort of thinking. I'm not going to do a lot more use cases, but I wanted to point out two little hot spots in the distribution area that I think we'll probably wind up talking about a lot. One is that GIS is almost always the facility records management system for as-built distribution feeders. So there's facility records, and the feeder as-built is in there. What about these other areas? As-built substation transmission, and Luke reminded me this morning, and I needed to add bulk generation and customer premises in here as well. It's not just feeders that we're concerned about. We need to build a complete electric system model. And the world we're going forward in is you've got activities in the distribution system that transmission guys need to know about because they need better load models to operate the system on, to project forward in time and keep the whole electric system reliable. We can't completely separate transmission and distribution as much as we used to. What products are handling new project designs? Are there different design tools, or do they get mixed in with the GIS platform? Who's doing as-built electric system models? That's up here in the blue part. A GIS could very reasonably be a distribution feeder as-built model. It might be cooperating with another model manager that was doing transmission. There are a lot of different possible scenarios in terms of who does what to whom. Future electric system models and the other functions providing electric model consumers with the modeling they need, which is this consumer assembly procedures part. Those are I think all of these areas are ones that you can argue different points of view about. And from our perspective, doing business function decomposition, what we want to do is not pick one, but we want to understand where the interfaces are between these various things so that the marketplace can work itself out with the winning strategies, and the product vendors can compete and all that kind of stuff. That's the way you get the best result. I'm just going to mention one other. Oh, come on. There we go. The other hot spot. If system operations is based on an accurate real-time network model, how is it maintained to reflect ongoing work? All right? This is a beast. All right? The world is going to get more and more demanding about that guy over there, just right there, it says real-time grid state. It's very small letters, but it's a very big thing. System operations, currently tries to maintain the real-time grid state, but what we're really looking for going forward is a real-time grid state that's supporting all sorts of analytics. That means you've got to have data quality to make all your algorithms function and perform reliably. So the standard for data quality out there and currency of information, bringing in information from customer meters, from SCADA, from all sources, and bringing that together as a complete state, tracking all of the construction activity. That's a real tall order. And this bubble in here is administering switching, which is in a constant dialogue with the crews in the field. I've drawn all of these arrows between electric system operations, crews doing work management and facility records management, electric system, and the network model view of the electric system. I've drawn them all double arrows. And that's because there are some genuinely interesting and feasible schemes that work in different ways. Is the information flowing basically from a GIS masters all flowing out, which sort of brings the GIS into the real-time world? Or is the information really being driven by this guy out here and flowing back down in? And lots of other sub-variations on those two themes.
Jay, I want to interrupt here for a minute.
Yep.
On a scale
Are
of
we-
1 to 10, let's get a volunteer. All right, so on a scale of 1 to 10, does anyone want to volunteer their view on how much they understand this diagram after that introduction? 9.5. 9.5? All right. Okay, you ruined my whole build-up. Because remember, the bullet one on this project was actually doing education. So one of the things we'll be doing is a series of webinars on this diagram and how we built it and what all the detailed boxes mean and how we differentiate business functions from applications and things like that. But we may be able to cut that short if everybody's at a 10. So
Understand and being able to solve it are two very different things, right?
yeah.
Well, and I wanted to say, I don't expect to solve this. What I expect to do is clarify the options, and again, this business function orientation, I feel, helps us focus on what would be required in order to make these two functions interoperate in a given way, not this is the way that it must be done.
That's a good lead into the interoperability. When we talked about selecting those interfaces, essentially we'll probably be using this as our way to discuss what will the interoperability interfaces be for our test. And it's literally which of the arrows on this diagram are the ones we would like to test. And those business objects, the square boxes, the data objects will be the things that are passed from one to the other.
I'm done. If there are any questions on this, this is a good time to raise them up.
I just want to make one comment. I think the problem is actually much more complex than saying that GIS is the facilities management, because if you think about it, we started working with Siemens. I'm from Bentley Systems.
Yeah.
We started working with Siemens, I guess almost 4 years ago, actually building a digital twin for power systems. And we've actually presented it several times now. In fact, the very first time we presented our solution, our very first build was to Exelon. And what we found out in doing that is that they actually had 27 systems of record times 5 operating units, right? So that's how many systems actually go into building what we are calling a digital twin rather than a network model manager.
Yeah.
But, so I think it's really, when you start thinking about that, you know, how many systems are involved, you have to think about also how are you going to manage all the data quality. And if you start thinking about it, even on top of that, how do you manage all the use cases? And you actually have to do it in an incremental approach, which I think is what you were alluding to earlier, that you wanted to understand use cases. So that means your solution has to understand, in terms of data quality, you have to be able to model each use case separately, profile, and when I mean profile, you profile it as it is in its systems of record, whether it's one system or whether it's 27. And then you also have to then model it in terms of what is it in your digital twin. So I think, to me, the answer is not that GIS is the model manager. I think there actually has to be a digital twin. In other words, a system that brings all this data together, whether it's federated or not.
Right. So sometimes I slip into saying GIS is, and that's mainly because GIS is so well established in this particular area for feeder as-built. But the way that the project should work is on a business function basis, not on a system basis. And you guys should be supplying the system sort of viewpoint of how these things might fit together.
To be very clear, we don't, as a project team, and we've had this discussion more times than I can count, we don't care if the GIS is the model manager or if GIS is supplying information to a model manager. So, you know, one application can take many of these functions, or you may take many applications to make one function. As long as we only really care about the utilities perspective to make sure the requirements are covered. How you folks want to package up your applications and pair with your partner suppliers and bring to the market these kind of solutions, that's completely up to you. So we want to make sure that what we're doing works for you and how you want to market your applications, if that makes sense.
Who's next?
That is the next. We're getting really close to being done. Lunch is out there.
Okay, so after all of you heard and seen, of course you like it, right? No, wait a minute, you love it, right? Love it. So the next question is, where and how do you sign up? That's where I come in. I am Annette Mosley, as Pat introduced me. I'm your technical advisor. So what that means to you is that I'm the gateway into all things EPRI. So that's like your project participation, your contract logistics, access issues, feedback, questions, starts here with me. So the next questions on your mind is what? How much does it cost, right? Oh. So here's a table that we created, and you can tell that according to the EPRI collaboration model like we do for our members, we have based the price on a tiered pricing based on staff size. So when you look at the price, so it's categories are what we say according to staff size. And we have it where you can either pay, the project cost is listed in the middle, but you don't have to pay it up front. It's not an annual cost, it's the total project cost. So you can pay half this year or half next year. And so you can see that, like I said, it's tiered. So EPRI always tried, the collaboration model that we have is that despite how big you are or how small you are, everybody should have an equal voice, equal participation chance to participate in our research. So that is the pricing. So any questions on that in the categories? We're going to talk more about the staff size on the next slide. Oh, I keep hitting the wrong one. Okay, the staff size is what we are, the staff that's supporting all your vendor products. That maybe they may be engaged in activities such as the engineering department, the maintenance, installation, training, support. It's all of those things, not just one. Anything that is used in the distribution domain.
Yes, so
So when we say staff size, that is exactly what we're talking about. So like she said, produces, manage, and what did the other one you said? Consume. Okay, what can you expect for your participation into this project? Here's your expectation list. You get to have feedback. That's probably the most, and in a room where well, I don't know how competitors you are between each other. You know, there might be a pro and a con for the rest of you, but you get at least to hear and provide your feedback to make sure we're developing a product that has your interest in mind. That you get a chance to engage in the model and data exchange development. Those things are valuable. Also, you get a chance to develop the software interfaces on one or more products. It doesn't have to just be one. And then you get to participate in the testing and demonstrating the products consumed to key data exchanges. So it's all up to you how you want to participate, how much you want to participate, but here's what you get from participating. So after you decide, I'm quite sure I have all the room wants to participate to see me. I start the process, I initiate it, I can tell you how you get started into EPRI, you know, how do you start the contract negotiations, or it's pretty simple. I navigate all that around, and then, like I said, Pat will be the one as for the technical part, but I'm the one for how do you engage, any questions. And I'm the technical advisor, not only for this project, but for everything EPRI, so in the PDU side of the house. So let me know if you have any questions. And who's up next? I think, Pat, is it you?
It is, okay. So I get to do the cleanup batting position? All right. So thank you for your patience and your interest today. We're really glad you were here. I just wanted, the last final thought that I wanted to share was just how hard we are trying at making this thing a success. We are really interested in making sure that it works. Not only do we have 9 utilities who have invested a lot of their time and energy and confidence in us, but you know, it's the right thing for the industry. We would really like it to work. And so I just wanted to sort of share with you quickly some of the things that are sort of evidence of that fact. We know it needs to be focused. We understand that there is sort of an ocean to boil here. And that's why we're only choosing or asking you to choose certain of the data exchanges to be the key ones that we're going to interoperability test. We understand that the process between here and the interoperability test is indeed a collaborative development one with a bunch of competitors. And so as we are looking at folks to guide some of that technical work to flesh out the common information model's support of those data exchanges, we are identifying people that aren't just good data modelers, don't just understand power systems or, you know, enterprise architect, but we're also picking people that are good cat herders and good leaders. So we're trying to make sure that we really drive this thing forward and get to a place where we can interoperability test something. We intentionally we listened to vendors a lot as we were crafting this project, and one of the suggestions from one of the vendors was, you ought to do a pre-event. Make sure you iron out all the kinks before you invite anybody else in the room. That event is specifically intended to encourage success, right? The goal of this is to make sure we've got things working. And lastly, we will see how good a job we did. But Randy and I tried very hard from the inception of this project to include EPRI's legal department in the conversation so that they were aware of the value of the project. They were sensitive to the fact that it was vendors who were participating. Okay, just a quick show of hands. How many of you have done work with EPRI before? Okay, it wasn't happy, was it? It was a lot of work to get that contract through. We know this, we have tried, our legal folks have told us that since the vast bulk of the results of the work gets made public, should make things a great deal easier through the contracting process. But anyway, Randy and I have done our best to streamline the contracting process so it isn't an excruciating 6-month ordeal. Anyway, with that, I thank you. There are lunches out in the hall, kind of snacky foods as well. I'm going to ask them if they can open up the doors for us. And at this point, we will just sort of do informal Q&A. If you got to go, that's cool, take a bag and run. We will be here all afternoon as long as people want to talk. So we've got Jay in town just today. If we want to get deep into architectural stuff, we can do that. We'd love to talk to you. So thank you. We appreciate your time greatly.